Welcome to the Maths for Graduates. Today we'll see what is the definition of relation in mathematics. So let's start. Suppose if we have two sets A and B, okay, and small a is some element of set A and small b is some element of set B, okay. Then if A is related to B, then we can write this as A R B. Here R is the relation, okay. If A is related to B by relation R, then we can write this in this manner, or we can also write this in form of order pair A comma B, okay. That means if R is the relation, then in set R we have elements of type order pair, okay. And we also know that A cross B has all the possible order pairs from set A to B. That means we can say that the relation R will be a subset of A cross B, right? Okay. I hope this is clear to you. Now let's frame this into a definition, into mathematical definition. So we can say that relation R is if A and B are two sets, then any subset of A cross B is a relation from set A to set B. That means any relation from set A to set B is always a subset of Cartesian product of A and B, okay. Okay, and this A cross B is also said to be universal relation from set A to set B. Now let's see some key point. We know that null set phi is always a subset of any set. So phi is subset of A cross B. So this phi is a null or void relation from A to B, okay. Now let's see an example. Let A is 2, 3, 4 and 5, okay, and set B has elements 4, 6, 8 and 9, okay. Then our relation R between A and B is defined as A is divisor of B, where A is element of set A and B is element of set B, okay. So in this example we are given that relation R is such that A is related to B and condition is A is divisor of B. That means A divides B, okay. Okay, now let's write some elements. 2 is element of set A, okay, and we know that 2 divides 4 and 2 divides 6 and 2 divides 8, right. So this is how element 2 is related to elements of set B, okay. Another element of set A is 3. 3 divides 6 and 3 also divides 9. So 3 is related to 6 and 9. And element 4 of set A, 4 divides 8, right, okay. Now 5, element of set A, last element of set A is 5. 5 divides none of the elements of B. 5 does not divide 4, 5 does not divide 6, 5 does not divide 8 and 5 also does not divide 9. So 5 is not related to any of the element of set B. So this is the required relation R. Okay. Okay. I hope this is clear to you. Now let's see a key point which will be very useful for your exams, for your competitive exams. If cardinality of set A is M and cardinality of set B is N, then number of different relations from set A to B will be what? Okay, that means we have to find number of relations from set A to set B. Okay, we know that a relation is always a subset of A cross B. Okay, that means number of relation will be number of subsets of A cross B. Number of subsets of A cross B, right? And cardinality of A cross B will be what? Cardinality of A into cardinality of B. Okay, so number of subsets of A cross B will be 2 raised to power cardinality of A cross B, right? And cardinality of A cross B is M into N. Okay, so this is the number of possible relations from set A to set B. Okay. Okay, I hope this is clear to you. Now this video ends here, and I have a quick announcement to make. Those students who are preparing for exams like CSR NET, GATE and other MS entrance examination can buy our real analysis handwritten notes for a very reasonable price for only ₹80. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.